The chalk beneath the sea just cracked. 30 meters below the English Channel. Water pressure building fast. Workers freeze mid-drill. No one speaks. Radios go silent for 11 seconds. Then a voice crackles through the tunnel. "We have a breach!" Behind them, 23 kilometers of finished tunnel. Ahead, unknown ground. Above them, the busiest shipping lane on Earth. This tunnel was never supposed to work. Geologists said the rock was too unstable. Engineers said the pressure was too extreme. Governments said the cost would bankrupt both nations. They built it anyway, and somewhere under the seabed, it almost ended everything. The breach alarm echoes through the tunnel. Steel door slams shut behind the crew. Chief Engineer Philippe Cosette checks the pressure gauge. His hands are shaking. "That's not supposed to move," he mutters. The gauge climbs past safe limits. Somewhere ahead, seawater is finding a way in. Nobody knows exactly where. The year is 1988. Construction on the Channel Tunnel began only months ago. Already, the ground is fighting back. Workers scramble to seal the boring machine. But the machine weighs over 1,300 tons. It cannot simply stop. It cannot reverse. It can only move forward, into the unknown. A geologist studies core samples taken days earlier. His face goes pale. The chalk marl layer they were promised is thinning. Beneath it lies something worse. Fractured rock, saturated with water. If the machine breaks through, the sea will follow. 23 kilometers from shore, there's nowhere to run. Cosette radios the surface. "We need to know what's ahead. Now!" The response takes 11 agonizing minutes. When it comes, nobody on site expected it. The survey maps drawn years earlier were wrong. Not slightly wrong, dangerously wrong. The tunnel was heading straight into a hidden fault line. One that could collapse under the weight of the ocean above. Cosette stares at the corrected survey. The fault line runs directly across their planned path. There is no way around it. Turning back means losing months and millions.
The fault line runs directly across their planned path.
Means gambling with the sea itself. The lead geologist, Marc Dubois, doesn't sugarcoat it. "If we hit that fracture wrong, we flood the whole line." Above them, ferries cross the channel every few minutes. Below, workers keep drilling, unaware how close they are. A decision has to be made within hours. The boring machine's cutting head grinds against harder rock now. Vibrations shake through the tunnel walls. A support beam creaks under the strain. Someone shouts to hold position. The machine stops, just meters from the fracture zone. Engineers lower a probe into the drilled path ahead. Water pressure readings spike almost instantly, higher than anything they've recorded so far. Dubois checks the numbers twice. "This isn't a small leak," he says. "This is a channel. A literal channel of water, hidden inside the rock. If they drill through it wrong, it won't seep. It will surge." Or to life. Thick sealant forces its way into the fractured rock. Workers watch pressure gauges in total silence. If the sealant fails, water floods the tunnel in minutes. If it works,
somewhere above them,
they've bought themselves a chance.
Is rising.
20 minutes pass. The readings begin to stabilize. A cautious cheer breaks out. Then the ground shudders. Not from the machine, from something else. A tremor ripples through the tunnel floor. Dust rains down from the ceiling. Cosette grabs the radio.
Cautious cheer.
"Report! Now!" Silence, then static, then a voice. "We've got movement in Section 14.
Get back! Get back!
Section 14 sits directly above the fracture zone. The sealant they just pumped in is shifting the rock. Unevenly, unpredictably. A support strut bends under new pressure. One worker, Alain Renard, is closest to the shift. He feels the floor tilt beneath his boots. He doesn't wait for instructions. He runs. Behind him, a section of scaffolding collapses into the dark. No one is caught underneath.
He feels the floor tilt beneath
but
his
the fracture
boots.
has widened, not
He
sealed.
doesn't wait for
The
instructions.
grouting didn't fix the problem. It exposed a second one. Somewhere deeper in the rock, another cavity is opening. And it's bigger than the first. Cosette pulls the crew back from Section 14.
This time.
Every engineer on site gathers around the new scans. The second cavity is larger than anyone expected. It stretches almost 40 meters beyond their current position. Dubois traces the outline with his finger, jaw tight. "This isn't a pocket," he says. "It's a void. A hollow space carved out by centuries of moving water. If the machine breaks into it without warning, there's no bracing fast enough. The tunnel could lose structural support in seconds. Someone suggests halting the project entirely. The idea doesn't last long. Too much money, too many governments, too much pride already invested. Cosette knows they can't stop, but drilling blind into the void isn't an option either. They need to see inside it first. A team lowers a specialized camera probe into a narrow borehole. The footage comes back grainy, distorted by water and dust. Then, for a moment, the image steadies. What they see stuns the room. The void isn't empty. Old timber supports, rotted and warped, brace the cavity walls. Remnants of a 19th century survey tunnel, abandoned decades ago. Nobody on the current team knew it existed. Records from that era were incomplete, some lost entirely. Dubois exhales slowly. "If that wood gives way while we're near it." He doesn't finish the sentence. He doesn't have to. Because right then, the borehole camera cable goes slack. Something on the other side just pulled it. Cosette yanks the cable back himself. It comes free, not torn, just caught on shifting timber below. Relief lasts only seconds, because the timber shifting means the old tunnel is failing. Right, but drilling into a collapsing 19th century void isn't survivable. Cosette signs off on the change that same night. Crews reinforce the original fracture zone permanently, this time with steel mesh and layered grouting. The new path avoids the abandoned tunnel entirely. Slower, safer. Weeks turn into months. The machine grinds forward, meter by meter, past the danger zone. No further breaches occur. On December 1st, 1990, workers from the English side and French side meet underground. They shake hands through a narrow gap in the rock. Above them, the channel that almost swallowed the project is finally beaten. The tunnel opens in 1994. Over 21 kilometers of it still runs beneath the seabed, deeper than any rail tunnel built before it. Millions of passengers cross it every year. Most have no idea how close it came to failure. No idea about the fracture, the void, or the forgotten tunnel beneath their feet.
How close it came to failure.
Some engineering marvels aren't remembered for how they were built. They're remembered because they shouldn't have survived construction at all.
Aren't remembered.
If you want to see how the world's most dangerous megaprojects almost failed, there's more waiting for you.